So today learning intentions is to look into the geometry of simultaneous equations. Geometry of simultaneous equations. So when we have two simultaneous equations, let's say ax plus by equals d and ex plus fy equals g. We have two simultaneous equations. Each simultaneous equation is a straight line graph. So finding the solutions is finding where those graphs of each simultaneous equation, where they intersect. And there are three possible cases. So case number one, when they have different gradients. When two lines have different gradients, they will have one unique intersection. That's one case. Different gradients, they always will intersect somewhere. Case number two, M1 equals M2. They have same gradients, but they have different y-intercepts. C1 does not equal C2. And what we will get in this case? Parallel lines. How many solutions there will be?
Zero.
None. Zero. So in this case, gradients the same, y-intercept different, no solutions. And the third case, when we have same gradient and same y-intercept,
Infinite.
in the same line, which will be infinite number of the one line going right above the second line. And if the question asks to find if you have equations and you have something unknown, and you need to find for which values will be one, no, or infinitely many solutions. And by the way, that's a typical year 12 final exam question, and it's for year after year after year done pretty badly. So straightforward and done pretty well. Let's consider example from the actual exam. That was 2011, 2011. Exam 1, so take 3 exams. You know there will be 2 exams at the end of the unit 3-4, 1 take 3, 1 take active. And so the question is, we have two simultaneous equations, kx minus 3y equals k plus 3, and we have 4x plus k plus 7, y equals 1. And question is, find value of k to those equations to have infinitely many solutions. So that is the last case when they will have same y-intercept, same gradient and same y-intercept. Question to you, do we need to rearrange these mechanisms of formula? No, don't need to.
That's crazy.
Same gradient will be if the ratio of the coefficients of x will be equal ratio of the coefficients of y. So if k over 4 will be equal 3 over k plus 1. If ratio of coefficients of x, sort of negative 3,
is it k plus 7?
if this,
Yeah, k plus 7.
k plus 7, ratio of the coefficients of x equal ratio of the coefficients of y. They will have same gradient.
Right.
Let's solve this. Yes.
Does it matter which order we put either thing? Could we do 4 over k and k plus 7 over negative?
We can, if you flip
As long as
both
they're
sides,
both the same.
if you will flip both sides, it will be same formula, same equation. So we will get k squared plus 7k equal negative 12, k plus 7k plus 12
K squared.
equal 0. If you factorize this, what it factorizes to? K plus 3 times k plus 4 equals 0. So k equals negative 3 or k equals negative 4. Now, we have two values for k for which lines have the same gradient.
Ooh.
But there are two possible cases. Lines are parallel or the same line. How we can distinguish which one is which? Substitute it in. Let's substitute negative 3. Substitute negative 3, we get negative 3x minus 3y equals 0. And we have 4x plus 4y equals 1. Is that the same line or not?
No.
Clearly not. So for what will happen for k when k equals negative 3? Lines are parallel and there is no solutions. Yes?
Couldn't you also put the ratios of the y's to the ratios of the constants and then see what they match?
Yes.
Yeah.
Yes, we can do that as well. And substitute that we used k equals negative 3, so that is no solutions. And we take k, by the way, it's not, we still cannot make conclusion at this stage that for negative 4 it's infinitely many. The possible that for both cases will be no solutions or for both cases infinitely many. You must check both. You cannot, if one is, you checked one, you cannot make conclusion that second one is another. You must to check it. K equals negative 4, we will get negative 4x minus 3y equals negative 1, and 4x, we will have 4x plus 3y equals 1. Clearly, it's the same equation. If we multiply this by negative 1, we get another one, the same equation. So we have infinitely many, infinite number of the solutions. Make sense?
Yeah.
Guess how many percent of your 12 students did this question correctly?
70%.
25%. Yes, that's right. 25% got this question right. Just 25%. And that was part A. Part B was question, find the values of k for which there is a unique solution. What will be the answer? For which values of k there will be unique solution?
So
Anytime
yes,
time it's not negative 3 or 4.
So we have that k
Does not equal to
belong is a real number except negative 3, negative 4.
Now, if you just wrote like k equals with the cross through it, negative 3, negative 4, is that wrong? Because if you don't
Yes,
know all
it is
this
wrong.
fancy writing stuff.
We will learn that in next topic more about this fancy stuff. So you can just, just 1 second, you can write that k does not equal negative 3 and
Right.
k does not equal negative 4.
Cool.
No, never mind, that's fine.
Yes.
So that fancy writing is. So
We will
any,
go,
anytime k is a real number, except for negative 3 or negative 4, it's a unique solution.
Yes.
Okay.
We will go over that, over those notations in the next area of study.
Nice one, Raphael Devani.
Okay, that's all new stuff for today. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas support Ukraine and Israel.